Hi, this is Alex from devstories.eu. Alembic Database Migrations, Episode 4 of 8. The easiest way to ruin a deployment is trying to drop a database constraint you never actually gave a name to. Your migration script works perfectly on your local machine, but the staging environment just crashed, complaining about a missing foreign key called something unpredictable like SYSC0029334. The culprit is relying on database-generated identifiers. This episode covers the importance of naming constraints and how to automate them. Many developers assume the object relational mapper handles dropping columns and their associated rules seamlessly. They define a unique constraint or a foreign key in their model, omit the name to save time, and move on. When you do this, the database engine takes over. Systems like Postgres or Oracle will auto-assign an arbitrary system-generated name to enforce that rule. This creates a ticking time bomb for future migrations. When you eventually need to alter or drop that table or column, Alembic uses the drop constraint operation. That operation strictly requires the target constraint's exact name. If you let the database generate the name, it will almost certainly be different in development than it is in staging or production. You end up hard-coding a local constraint name into your migration script, which immediately fails when run against a different environment where that random string does not exist. To fix this, every single constraint in your database must have an explicit deterministic name. Doing this manually across hundreds of models is tedious and easily forgotten. The better approach is to configure a naming convention dictionary on your SQLAlchemy metadata object. This dictionary serves as a global template for your application. You define rules for each constraint type. For instance, you can specify that every index should be named using the prefix ix, followed by the table name, followed by the column name. You set similar templates for unique constraints, check constraints, and foreign keys. You then attach this configured metadata object to your declarative base class. Here is the part that matters. Once this dictionary is in place, Alembic automatically integrates your naming conventions into both its auto-generate feature and its manual operations. When you run a command to auto-generate a new migration, Alembic looks at your models, sees a new constraint, and checks the metadata dictionary. It applies your template, calculates the explicit name, and writes that exact string into the generated Python script. Because the generated script explicitly commands the database to use that specific name, the constraint will be identical across every single environment. This integration extends to Alembic operations run during the upgrade process itself. If a migration script includes a create table or add column operation with inline constraints that lack explicit names, Alembic doesn't just pass them blindly to the database. It intercepts them, consults the naming convention template, and assigns the correct deterministic name before executing the database commands. A deterministic naming convention guarantees that a rule created on your local machine will share the exact same identifier when it reaches your production servers, entirely eliminating the risk of undroppable constraints. Thanks for listening. Take care, everyone.